is Angelica Coriano. I'm a student of Valencia College in the Bachelor's for Electrical Engineering Technology degree. This is my video submission for lab number 8 for CET 2114C, which is Digital Systems for Professor Evans. This lab is going to include every single part. If I'm not wrong, it's parts 1, 2, and 3. We'll begin with part 1, number 1, right now. So for this circuit, I'm holding this because I'm using a separate breadboard because I noticed with the breadboard on the lab kit, it doesn't have all the pins connected correctly, so I'm using this separate breadboard. I have the 7493 IC chip connected here, which is the mod 2 and mod 8 counter, which can be wired to make a mod 16 counter, which is what we have right here. So, beginning from the left-hand side, pin number 14, I have CP0, which is the clock input for the mod 2 counter. That black wire is connected to logic switch A. And then the output of mod 2 counter is pin 12, which is this orange wire right here. That one is also the blue wire. It's connected to LED 0, which is the A output. And pin 12, which is the output of the mod 2, is wired into pin number 1, which is the clock input of the mod 8 counter, so that way they are cascaded to make the mod 16. Pins 2 and 3 are MR1, MR2, which are the master resets. They're connected to ground so that they don't reset. Pin 5, pin 5 is connected to the VCC. That's the VCC input for the chip. And VCC is connected to the 5-volt VCC. It's connected right there. That is a positive rail. It's connected to both sides. I jumped them. And then I have the negative, the ground, connected to the generator ground. And both sides are connected too. That is why I have my VCC running here. On the other side, pin number 10, so 8, 9, 10, this little blue wire right here is connected to ground. That is the ground input for this chip. And then we have the outputs of the mod 8 counter, which are, according to the chip diagram, Q1, Q2, and Q3, but I'm going to define it as Q, B, C, and D. So QB is pin number 9, right over here, this yellow wire, and it is connected to LED, my bad, actually, no, I had that one wrong. That's pin number 9. No, I think I got it right. There it is, yes. So the yellow wire is connected to LED number 1, which is output B, QB. So pin number 9, QB. Pin number 8, which is right next to it, this white wire, is QC. QC is connected to LED number 2. As you can see, the C on top is what I wrote. I do erase them. I write it in pencil for that reason. And then we have pin number 11, which is next to right here, is this red wire. This is pin number 11. This is QD, and it is connected to LED number 3 to make DCBA, with output D, QD being the MSB, most significant B, most significant bit, and QA being the least significant bit. And that is how my circuit is wired. Going through these first part, we're going to pulse letter F, pulse CP0 16 times, which is logic switch letter A, and record the outputs in A1. And this is my table A1. I have it right on top of my keyboard, so I'm going to actually just pulse through and then write those answers in later. So let me turn on my board. That is what I have. So it's going to be 0 through 15, which is 16 pulses. 0, I have 0, 0, 0, 0. I'm just going to let the board hang there. I promise it's still wired correctly. I'm going to pulse it once. I have 0, 0, 0, 1. Another time. 0, 0, 1, 0. 0, 0, 1, 1. 0, 1, 0, 0. 0, 1, 0, 1, which is 5. And then 6, 0, 1, 1, 0, 7, 0, 1, 1, 1, 8, 1, 0, 0, 0, 9, 1, 0, 0, 1, 10, 1, 0, 1, 0, 11, 1, 0, 1, 1, 12, 1, 1, 0, 0, 131101, 141110, 151111, and then it resets back to 000. So this mod 16 counter is working properly. And that is part number 1. So now beginning with part number 2, we were put to modify our 7493 IC chip so that everything is wired basically the same except QA and QD. QD is wired to MR1 and QA is wired to MR2. So basically at 1001, the master resets are going to kick in and reset the entire circuit. So this is going to be a mod 9 counter. I'm going to show my circuit right here and explain how it's wired right now. So now I'm going to be going through how this circuit is wired. I have yet again the 7493 IC chip here. The left hand side pin number 14 is connected to the logic switch because pin 14 is the clock input for the mod 2 counter. Then we have pin 12, which is QA, still connected to LED number 0. Then we have pin 9, which is the yellow wire, connected to LED number 1, which is QB. Pin 8, which is QC, is connected to this white wire, LED number 2, which is right there, QC, LED number 2. And then pin 11, which is the red wire right here, is connected to LED number 3, which is QD. So for this one, what's the difference is we have the master resets connected to QA and QB. So MR1, which is pin number 2, is connected to pin number 12, which is QA. As you can see, that little purple wire when it running across. MR2 is connected to pin number 11, which is right next to it, which is the output DQRD MR2, and that is going to create a reset. This wire is not doing anything besides trying to hold up my circuit, so I do apologize about that. Ground is still connected from the generator. VCC is connected from the 5-volt VCC to the positive rail. Both sides are connected. That way I have pin number 5 connected to the VCC because that is the chip VCC. And I have pin 10 connected to the ground, which is that little blue wire right there, because that is the ground in for the circuit. And that is how my circuit is wired. And we're going to be going through each part right now. So it is saying to pulse 16 times, take a picture of my circuit, and determine the mod number. I already took a guess at the mod number just because QA and QD are both going to go high and reset this counter. So I took a guess it's a mod 9 from 0 to 8, but we're going to test it right now. I'm going to write those inputs in afterwards because it is on top of my keyboard. So, let's try to reset this. Go back to 0. Do apologize. 0. Pull 0. 0. 1. 0, 0, 0, 1. 2. 0, 0, 1, 0. 3. 0, 0, 1, 1. 4. 0, 1, 0, 0. 5, 0, 1, 0, 1, 6, 0, 1, 1, 0, 7, 0, 1, 1, 1. It went to 8. I promise it went to 8. Let me try it again. Let me see if there's just a mistake in the way I wired it. 7, 8, 1, 0, 0, 0. That was the 15th. That was my bad, not the 15th. The 9th pulse. 0, 0, 0, 0. And then it would reset, and we're going back up to the top. 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, and reset. And that is basically how this circuit works. It is modified to be a mod 9 counter, so to go from state 0 to 8. And that is the inputs I have. And that's it for part number 2. So beginning out with part number 3, we were told to connect two 7490 IC chips so that they would create a mod 60 counter by creating a mod 10 counter. and a mod 6 counter, and then connecting them. This is my circuit right here. I want to explain how they're connected right now. Once again, this is the circuit right here. So I have a 7490 IC chip on the left and another one on the right. The one on the left is a mod 10 counter. This one on the left is going to be going to LEDs number 0 through 3. And the one on the right is going to be going through to LEDs 4 through 7. I will show where and which ones in just a second. The clock input of the first one of the mod 10 is going to these 1 hertz. As you can see, it's pushed to the 1 hertz clock signal. So that's pin 14. It's clock signal. Yes. And then I have the outputs, which are A, B, C, and D. A is pin number 12, which is 2 over, which is this, please focus, white wire going to LED 0, pin 12. Then I have QB, which is pin number 9, which is this yellow wire going to QB. Then I have QC, which is pin number 8, which is this red wire going to LED number 2. Then I have QD, which is pin number 12, which is this blue wire going to LED number 3. That's the first output of the mod 10 counter, 0 through 3, which is going to count 0 to 9. To make it connected to a mod 10, I have the output of the mod 2 counter, which is QA, connected to the clock input of the, let me reconnect it, to the clock input of the mod 5 counter, which is here in pin number 1, which is the clock input. For this one, MR1, MR2, and the other 2 resets are connected to ground so that this can count to 9 with no issues. I have the VCC in pin 5 connected to VCC. Yet again, VCC is connected to the 5 volt. Ground is connected to the ground in the generator, and they're both bridged. So VCC is connected here for this pin, and the same thing here. Pin number 5 is connected to the positive rail. Pin 10 are these 2 small blue wires. Those are the ground inputs for the chips, and they're both connected to the negative rail. I have on the chip on the right, the second resets, MS1 and MS2, are connected to ground so that this can count. But since it's a mod 6 counter, I have the outputs, so pins 8 and 9, which are C and B, connected to master resets 1 and 2. So C is connected to master reset 2, and B, which is pin 9, is connected to master reset 1, which is pin 1. Pin 2 is connected to pin 8. Pin 8 connected to pin 2. Pin 3. Oh my goodness, I do apologize. I keep me. Output C, which is pin 8, is connected to pin 3, which is master reset 2. Output B, which is pin 9, is connected to pin 2, which is master reset number 1. I have to slow down. Yeah, going too fast isn't helpful. So this is the mod 6. I made it that way so that once it hits 0, 1, 1, 0, which is C and B being 1, it resets and it only counts to 5. So 0 to 5, a mod 6 counter. The clock input of the first counter here is the output D. So this is QD, which is pin number 12. My bad, pin number 11. Pin number 11, which is the output D, is connected to pin number 14, which is the clock input for the first counter, the mod 2 counter. Then I have the output of that mod 2 counter, pin number 12 of the second chip, connected to pin 1, so it can become the clock input of the second counter. Because I made what I've made on this right hand side is a mod 10 counter, but I modified it using the master resets to make it only count to 5. So I created the mod 10 by connecting the mod 2 to a clock signal. Then the output of mod 2 is connected to the clock input of the second counter. And then these outputs, C and B, are connected to the master reset so that it'll reset at 6 and only count till 5. These resets are connected to 0 so that this counter can count. And then I have the outputs. So, words are hard. Pin 12, which is QA, This blue wire is connected to LED number 4. QB, which is the second output of this second chip, is this white wire. It's pin number 9. It's connected to LED number 5, as you can see right there, LED number 5. Then pin number 8, which is output C, it's going to focus in right now, output C, is connected to LED number 6. And then the last output pin number 11, which is output D, it's 8, 11, this black wire is connected to pin 7. So basically the way this is connected, the first IC chip is these four LEDs, the second IC chip is these 4 LEDs. That way I can have 0 through 5 count here and 0 through 9 count here. They are cascaded to make a mod 6, because once the D output of the first chip hits 1, which is high, which it does with, once it goes high, it's connected to the clock signal and it resets at 9. So once 9 hits, it goes 1000 for 8, 1001 for 9, and then it clears out again. Once that clear happens, that's when this counter is going to start and go to 1. This is going to count from 0 to 59, which is a mod 60 counter. We're going to see it happen right now. It started in the middle. I'll wait till it resets so I can show. But so you can look at it, and I'll count up with it. So this is like the 10th place, and this is the 1's place. I'm going to let it go a little bit before I count with it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, and reset. And that is this circuit and part 3 completed. One thing I do want to answer a little bit here is input frequency is 1 kilohertz, calculate output from QC. Why QC in the mod 6? I believe here, and to answer this part, I will go through and I'll do the F out. Basically, F out is equal to F in divided by the mod number. And I'm going to be going through each one and calculating that one. The reason we're using QC instead of QD for mod number 6 is because we modified it so that it only counts till 5. So 0110 is where it's going to be affected. It's only going to count to 0101, which is C and A. And C you want to have activated because that is actually one of your counts. So it's 50, 0101, D, C, B, A. If I do D, it's going to be 0 because it's not going to go up to D. At no point is it going to go up to 6, so it doesn't need to count that D. And that is why we're using QC for the mod 6 instead of QD. And then these just follow the simple FL equals FA divided by mod number. And that is part number 3.